A lifeguard stands on the burning sand, spotting a drowning swimmer in the rough surf. To reach the victim in the shortest amount of time, the lifeguard does not run in a straight line. They sprint longer on the sand, where they are fast, and minimize the distance they must swim in the water, where they are slow. This is a calculation of optimization, a conscious decision made by a thinking brain to save a life. But light does the exact same thing. When a photon travels from air into glass, it bends. It changes direction. It refuses the straight path, opting instead for a jagged route that mathematically minimizes its travel time. This is Fermat's principle, and it immediately breaks our understanding of cause and effect. The lifeguard has a brain to compute the variables. A beam of light does not. A falling rock does not. Yet every single particle in the cosmos behaves as if it has performed a complex calculus derivative before it moves an inch. This phenomenon expands beyond optics into the very bedrock of classical mechanics, known as the principle of least action. Whether it is a planet orbiting a star or a ball thrown across a field, matter always moves along a trajectory that minimizes a quantity called action, essentially the difference between kinetic and potential energy integrated over time. The math is elegant, precise, and completely terrifying. To minimize a value over a specific journey, you need to know two things: where you started and where you will end. The equation demands the destination as an input. This implies that the particle, at the moment of launch, is already aware of its landing spot. It suggests that the future is reaching back to shape the present. In philosophy, this is called teleology, explanation by purpose rather than by cause. It suggests the universe is not a machine pushed forward by the past, but a narrative pulled forward by the future. For centuries, this lazy universe paradox haunted physicists. It made the cosmos look less like a clockwork mechanism and more like a simulation running a pre-computed script. If a simple electron effectively sniffs out the most efficient path before it moves, it implies a level of awareness or predetermination that science tries to avoid. We are left with a chilling question. Does the stone fall because gravity pulls it, or does it fall because the ground is waiting for it? The math works both ways, but our intuition screams that the universe cannot possibly be scanning the future to optimize the now. This is the teleological glitch, a crack in the causality of the world that stood unexplained until quantum mechanics tore the floorboards up to reveal the chaotic machinery underneath. From that paradox emerges a solution that is arguably stranger than the problem itself. The universe is not predicting the future, nor is it conscious. It is simply hallucinating every possible reality at once. In the mid-20th century, Richard Feynman looked at the principle of least action and realized that we were asking the wrong question. We assumed the particle takes one path, the best one. Feynman proposed a radical reformulation of quantum mechanics known as the path integral. His assertion was absolute. The particle does not choose the efficient path, it takes every path. When a photon travels from a lamp to your eye, it does not just fly in a straight line. It travels to the moon and bounces back. It loops around the nearest black hole. It zigzags across the galaxy. It travels to the edge of the observable universe and returns. It takes infinite paths simultaneously. This sounds like madness, a complete breakdown of physical law, but the math reveals a hidden order within the chaos. In the quantum realm, every possible path is associated with a mathematical arrow called a probability amplitude, which has a specific phase. For the wild, erratic, inefficient paths, the ones that go to Mars or loop in circles, the phases vary wildly. They are out of sync. When you add them up, they cancel each other out, a phenomenon known as destructive interference. The math annihilates these histories. They sum to zero. However, for the paths that are very close to the lazy, efficient trajectory, the phases are nearly identical. They line up. They reinforce each other through constructive interference. The probability amplitude spikes. What we perceive as the solid reality, the predictable arc of the ball or the straight beam of light, is not a singular event. It is the mathematical residue where the quantum probability is highest. It is the only part of the storm that didn't cancel itself out. The universe isn't lazy, it is infinitely hyperactive, exploring every conceivable history in every fraction of a second. The classical world of cause and effect is just the statistical average of a quantum storm. We are not living in a determined clockwork. We are living in the survivor of infinite ghosts, walking the one thin line where the universe agreed with itself.